So degree of dissociation alpha. Dissociation reaction is a chemical reaction whereby a molecule is broken down into smaller molecule, atoms or ion. So in this case, reactant is actually a molecule that is broken down into a smaller molecules, atom or ion. So if the dissociation occurs completely, so alpha will be 1. If you calculate for percentage of dissociation, it will be 100. So how to calculate alpha? Alpha is equal with concentration change. In other words, it is concentration for molecule that is dissociate. So in this case, we will look at our ice table. So we look at reactant. So we take the value at C part. Okay, concentration change for reactant. Concentration change for reactant ni merujuk kepada concentration molekul yang dissociate lah. Bahagi juga dengan initial concentration. So for question A, we already learned in 6.2. So we only look at how to calculate alpha. So alpha is the concentration change divided by initial concentration. So we look at our reactant. So our reactant is PCl5. So PCl5 is broken down into smaller pieces. So we look at X value here. Okay, we ignore the negative sign. So if here is 2x, negative 2x, we only take 2x. Okay, the negative sign we ignore. So concentration here divided by initial, so we will get alpha. Consider the decomposition of hydrogen bromide in the following equation. Initially, 1 mole HBr is placed into 2 liter flask and allowed to reach equilibrium. At equilibrium, the concentration of hydrogen is 0.15 molar. Calculate the degree of dissociation of HBr. So if the question gives initial quantities, definitely we need to build up ice table in form of concentration because provided concentration of hydrogen at equilibrium, which is 0.15 molar. So 1 divided by 2, so the initial concentration of HBr is 0.5. So the change is negative 2x. Okay, so for product 0, x and x. So given in the question at equilibrium, concentration of hydrogen is 0.15 molar. So we know value of x, so we can calculate alpha. Alpha is the concentration that is dissociate. So here is referring to 2x. Okay, so 2 times x, 2 times with 0.15 divided by initial, so the answer is 0.6. If the question asks percentage of dissociation, so the answer is 60%. Predict the direction of net reaction by comparing the values of reaction constant Q and K. So K is the equilibrium constant. So the value of constant value at equilibrium. Okay. So Q will have similar expression like K. The difference is Q, we will take value of concentration at any point. Maybe at equilibrium, maybe not at equilibrium. So for K, the value must be concentration at equilibrium. So for K is definitely value concentration at equilibrium. So we will compare value K and Q to check whether the reaction already achieved equilibrium or not. If Q is equal to K, meaning the system is at equilibrium, so no net reaction occurs. Okay, so if Q is smaller than K, so the reaction is not at equilibrium. So in order to reach equilibrium, the net reaction will shift to the right until Q is equal to K. So Q ni sama je expression macam K. Beza dia adalah kita masukkan nilai concentration or maybe partial pressure at any point. Sebab kita nak check sama ada sistem dah achieve equilibrium ke tidak. Okay, so kita akan compare dengan value K lah. Okay, so kalau dia lagi kecil, so in order nak achieve equilibrium, the net reaction will shift to the right. So macam mana nak ingat? Kita akan ingat Q tu sebelah kiri, K tu sebelah kanan. So kita ingat mulut Pac-Man kita. So mulut Pac-Man kita makan, so bergerak ke sebelah kanan. Tapi position K dengan Q tu jangan berubah. Q sebelah kiri, K sebelah kanan. So kalau Q lagi kecil daripada K, so lagi kecil, so kita buat Pac-Man kita. So Pac-Man kita tengah makan K, so dia bergerak ke sebelah kanan lah. Okay, kalau Q lagi besar daripada K. So kalau kita main game Pac-Man, in order to achieve equilibrium, the net reaction will shift to the left. Okay, so we look at example. At 375 degrees Celsius, the concentration of H2, N2 and NH3 given. If the equilibrium constant is 1.2, decide whether the system is at equilibrium. If it is not, predict which will be reaction, proceed. Okay, so if the question asks you to check whether the reaction is at equilibrium or not, so definitely you need to calculate Q. Q will have same expression like K. So given Kc, so right now you need to calculate QC. So product over reactant, and then we will take the stoichiometric coefficient. So given concentration here, so we do not know the concentration is at equilibrium or not. So we just insert the value. So we get Q 0.61. So compared with K value, which is 1.2, so Q is smaller than K, so the reaction is not at equilibrium. Okay, so in order to achieve equilibrium, the net reaction will proceed to the right. So very easy to memorize this one. So ingat macam geng Pac-Man lah. Q lagi kecil daripada K, so ni mulut Pac-Man dia, so ni Pac-Man dia. So the net reaction will shift to the right.